All right, guys, this is dimensional analysis. Dimensional analysis is just a fancy way of saying unit conversion. The reason it's called dimensional analysis in connection with unit conversion, it's like, let's say length. Length is there's many different units of length that you can have. You can have meters, miles, kilometers, centimeters. There's lots and lots of different units for length, but they all fall within the same dimension of distance or length, right? And so that's what we mean by dimensional analysis. We're just doing a unit conversion within one dimension. So from one unit of length to another unit of length, for example, okay? So this becomes important in chemistry as we get a little deeper into this course, but let's learn how to do the basics here. I'm just gonna start with a quick question. How many miles are equivalent to 10 kilometers? Okay, so all we're doing is we're gonna convert 10 kilometers into a new unit of length that we're familiar with, miles, right? And here's how you do that. You set up what's called a dimensional analysis cross. And they can be sort of simple looking, or they can be a little bit more complicated looking. So here's what a dimensional analysis cross is. It's just a horizontal line and a vertical line. Now, this is really representing a fraction, as you're gonna see here. This horizontal line separates the numerator, which is up here, from the denominator, which is down here. So into this cross, you're gonna be putting a series of numbers. This spot up here at the upper left, this is really sacred ground. This is the number or measurement from the problem. So in our case, the number from the problem was 10, right? And you have to remember to include units when you do this. And you'll see why that becomes important as these get a little more complicated. On this side, over here, you have what's called a conversion factor. And conversion factors is just a formula that's used to change one amount of units to an equal amount of different units. And so we've got to find some way to equate miles and kilometers with this conversion factor, okay? And so the units that you put on top and bottom of this line are really important. So you always want to match up your original unit from the problem with the bottom part over here. So in this case, we'll go through this problem, but this is eventually going to be 10 kilometers, and you want your kilometers unit to be down here as well. That's because we don't want to answer a question in kilometers. We want to actually get rid of that unit. And remembering that this is a fraction, you know that if you have the same unit as a numerator and a denominator, you can cancel them out. So that's why we do it that way. The unit that you want to be left with or answer the question with goes on top of the spot here, okay? So the other thing to remember here in connection with significant figures is that all conversion factors are counted numbers with infinite significant figures, okay? And so what that means is, like, I'll show you this cross and then it'll make more sense. These are, they appear to be measurements. And at one point we were thinking that counted numbers just couldn't have decimal places because you count in whole numbers, right? But this is one of the exceptions where you have what appears to be a measurement, a number with a unit of measure here. But these conversion factors are always going to be counted numbers. So, like, for example, there are exactly 0.621 of these miles in a single kilometer. And that's how you can think of it, as a counted number. And as a matter of fact, this 10 kilometers, this is not a measurement either. This is not a measurement. It seems like it would be, but all we're doing is converting this exact number of a unit of distance into another value of a different unit of distance, okay? So let's actually work this problem. I'll show you how this goes. So when you have the same unit on top and bottom, like the kilometers is, you can just cross those off. They go away, okay? They are no more. Leave the numbers in place, obviously, but just the unit gets canceled out. And at this point, what you're really looking at is 10 times times 0.621, all divided by 1. Okay, that's what the math looks like. So you can see that this is a pretty normal looking fractional math problem minus this vertical bar that's in here. This just separates your starting point from your conversion factor. Okay, so when we do the math here, 10 times 0.621, oops, that gives us 6.21 miles. And we know that because we know it's in miles because that's the only unit that's left after we've crossed out the kilometer units. Does that make sense? Now, not every one of these things is going to start with a counted number here. If you start with a measured number up here, then you've got to adhere to some sig fig rules, okay? So here's a kind of a cool little bit of trivia that I found here. The longest throw in baseball history, this was back in 1957, I guess, was 135.89 meters. Now that is a measurement. That is the ball has traveled a certain distance that had to be measured to get this number, okay? So this is a little bit of an uncertainty value, which means we're gonna have to adhere to our sig fig rules. The question is, how many feet is that? So we're just gonna be converting between feet and meters. And here's the conversion factors and the dimensional analysis cross. So we start with our given number from the problem, 135.89, along with its unit, meters, right? And then we use the conversion factor between meters and feet on this side. And 1 meter, there are exactly 3.28 feet in that meter. So let's go ahead and cancel off our like units here. Meters, bye-bye meters, and we're left with our desired unit of feet. And so let's multiply these numbers. And oftentimes you'll end up with a 1 down here in the numerator position. If you do, you can just leave it out and just multiply the top numbers. That's what I do. 135.89 times 3.28. Okay, so that gives us this many feet. 445.792. So we cannot report that number exactly. We've got to round it to the nearest number of significant figures from the problem. And since this was our original measurement with 5 significant figures, we've got to trim this number down to 5 significant figures. And so all we have to do is, you know, count out our 5. It's those first 3 and the 7 and the 1, and then how does that 9 affect the 1? Turns it into a 2, right? So our final answer, our final rounded answer is 445.72 feet. Okay? So that's an example if you have like a measured number, which lots of times you will. All right, let's do a couple more. So here's another measurement one, and it reads, a student measures 1.63 liters of water in lab. So that's a measurement. How many pounds of water is that? So this one, you know, you might not have a single conversion factor that's gonna work for you. Like, I don't really know off the top of my head a conversion factor between liters and pounds, because, you know, different substances have different weights and things like that. And so we really have to do some digging to find the correct conversion factors to use. And this is where the line, if you have more than one stop along your conversion, that you might have a pretty long line of conversions to make. So let's go ahead and start this off. 1.63 liters of water, okay? So I know a few conversion factors. I know that 1 liter is equivalent to 1,000 milliliters, okay? And if we were to stop and solve the problem there, we would be answering in milliliters, but we don't want to do that, okay? So we gotta do another one here. And I know that in 1,000 milliliters, is equivalent to 1 kilogram of water. Okay. And that's actually for water only. And I also know that 1 kilogram is equivalent to 2.2 pounds. All right. And so once you get to your desired unit that you're trying to get to, that's where you stop, right? And if there is a fun part to this, it's crossing out the units. So let's look for units that exist on top and bottom and go ahead and cross them out. Liters go away, milliliters go away, kilograms go away, and we're left with our desired pounds unit here. And now we're just gonna multiply across the top and then divide by the denominator. And really, like, cleaned up, this would look like this: 1.63 times 1,000 times 1 times 2.2 all over 1 times 1,000 times 1. And so, you know, you guys are smart enough to leave the ones out of here if you want to, but that I'm just bringing them down here to show you what that fraction really looks like. So let's go ahead and multiply these out. 1.63 times 1,000 times 2.2. So that's 3,586. And because this is because we're doing our multiplication and division in the same problem, we can trim our final answer down to the 3 significant figures once we make the division, okay? Divided by 1,000. And that's 3.586. Okay, and then according to the measurement and the number of significant figures in the measurement, we're limited to 3. So this becomes 3.59 pounds. Okay. And believe it or not, yep, it's points off and it's wrong if you report in the incorrect significant figures. Okay. One last one that we need to talk about with dimensional analysis is looking at dimensional analysis with a rate. And a rate just means it's 1 unit over another unit. So like miles per hour. You know, it's sort of a derived unit that includes 2 different dimensions. So we have a distance unit over a time unit, right? And we got to convert 40 miles per hour, which is like a speed you might drive in your car, and we want to convert that to centimeters per second. Okay, so this is where you'd start out with your same number here, 40 miles. And up until now, we haven't had anything down in this lower spot, but this is where you would put the whatever comes after the word per, and this is 1 hour. Per hour. That just implies per every 1 hour you're driving 40 miles. Okay, so we have to sort of split these units up and convert them separately. So I don't know. I think I'm just going to start with the distance dimension first and go from miles into centimeters, and then I'll come back for the times. So I know a couple of these conversion factors. I know that 1 kilometer is equal to 0.621 miles, right? So we got to ditch the miles unit here. And I also know that 1 kilometer is equal to 1,000 meters. And I know that 1 meter is equal to 100 centimeters. Okay, so if we forgot about this hour down here and just did this problem across, we would have converted 40 miles into centimeters, right? But we're going to keep on keeping on here, and now we're going to do our time dimension. And so now we're focusing down here on the hour. Okay, so 1 hour. And the reason I'm putting it up here is that I want that hour to cancel off, so it's got to be on top and bottom of the horizontal line. Okay, so 1 hour is 60 minutes, and maybe 1 minute is 60 seconds. Cool, so there's our seconds. So now, the only sort of fun part here, we can begin to cross off all of the like units here. Miles, you're gone. Kilometers, you're gone. Meters, you're gone. Hours, you are gone. Where are you? There you are. And then millimeters, you're gone. And the only units that we have left that don't have a matching partner on the top or the bottom is centimeters per second, right? And so now we can just do the math here. It's pretty easy. It kind of ends up looking like this. 40 times 1 times 1,000 times 100 times 1 times 1. That's all of these top values. Okay, that's its own problem. And then we're going to divide this by the product of these bottom numbers. 1 times 0.621 times 1 times 1 times 60 times 60, okay? And this, remember, the only unit on the top is centimeters, and the only unit on the bottom is seconds. So just to finish it off here, let's do the math. And 40 miles in 1 hour. That's a counted number. That's 40 of these things in 1 hour. So these are counted. So that makes for easy reporting. So 40 times 1,000 times 100 equals. So the top number is 400,000. And we're going to divide that by 6.621 times 60 times 60. And the bottom number is 2235.6, okay? And let's just divide those numbers. Once you can do that, we're gonna really be in centimeters per second. So 400,000 divided by 2235.6. Okay, so that is 178.9 centimeters per second. All right, so that's how dimensional analysis works with rates. And the more you do of these, you'll see there's some shortcuts you can make for yourself. And the only other thing is that you kind of have to be given some of the conversion factors, unless you just have them memorized, but you'll have access to that stuff. All right, so that is dimensional analysis. I hope that helps.